sleepy and sixth hour, I get weird. So instead of doing this one in your notes, because it's a similar one, I'm going to do number 12. So if you, Rowan, can you tell me what number 12 is? It's the tan line at 1 comma 1. So you're supposed to find the area of the region enclosed by those two things. I was just a little worried that the tan line part of it, because they didn't explicitly give you the equation, maybe you didn't get that one. So graphically, x cubed is going to go like this. You have some tangent line at 1, 1 that's hitting it. And in order for you to set up your integral, you need an equation for the tangent line. So we have to go back to like chapter 2. What two things do you need for an equation of a tangent line? Point and a slope. And the point's staring you in the face. So I know it's y minus the y I know is equal to the slope there times x minus the x I know. I just need to contribute the slope there part, right? And in this class, the slope of a tangent line is always its derivative there. The derivative of x cubed is 3x squared, which right there, what's 3x squared going to be at 1, 1? 3. So I'm going to solve it for y because you want to have these solved for y. So that would be what? 3x minus 3, and then I'd add 1 to it. So it's 3x minus 2. This is the other line you're supposed to graph. So if you went on your graphing calculator, because I told you you could use the calculator to graph them, just don't use it for the integration part, but that was a calculator active anyway, so you could use your calculator on that whole thing. When you go to 1, 1 and draw the tangent line, did anyone graph it on their graphing calculator? You figured, did it run like this just because I have a bad graph? Okay, I was just making sure. I want to make sure I know who the top. I'm going to make that dot bigger so it looks like the intersection. So I need to integrate from intersection to intersection. I already know this one's 1, right? What was this one over here? Negative 2? Yeah, you could calc intersect, or I can even see a negative 2 contributes a y of 8, and a negative 2 here also will. So I could do that one by sight. And then remember, we do top function. Which one of these is on the top? X cubed, do you remember yesterday I said if they're so close together, zoom in on your calculator and it will, they'll separate clearer. So that would be x cubed minus, and then I'm going to purposely do a very common mistake. Before you go math 9 that will give you a wrong answer, and it's a very common mistake. What is it? Parentheses, yeah. So when you think top minus bottom, think top minus, and it's bottom like that. Otherwise, you'll make a sign error. So that needs to then get math 9 because it was calculator active. Can somebody who math 9 it? Or the answer's on there. So 6.750. There's one like that on your problem set today. It's the fourth one. So this assignment should have taken you maybe a half hour-ish. Is that about right? Then the one today is a lot shorter because it's only 4 problems. In first hour, most of them got 2 or 3 of them done in class. But I'm going to give you the one that I'm going to assign on Monday, just in case some of you want to work ahead. Timothy, here you go. Are you in trouble? No. I feel so ridiculous in these headphones. All right, anyway, we are going to pass that up. And then we have a fairly big chunk of notes today, but on Monday I hope to let you just work the whole hour, if not really close to the whole hour. I got to get a few more notes in. I'm going to pause this while you're passing those up. But this page in your notes, what we're going to do is very similar. We're in the same section to what you did yesterday. And I'm going to tie it in with a really easy function. I'm going to show you how we're getting the same answer 2 different ways. And then we'll decide when we should use the new way or not. So this one right here, I'm doing only for the sake of being able to compare it with what I do when I tweak it. So go and graph the function given. It's the square root of x. It's that shout out function from 0, 0. And then go put your other constraints on there. I've got y equaling 0 is going to bind it. So the x-axis is also enclosing my area. And then the line x equals 4 is enclosing my area. The region bound by all 3 of those is right here. So go shade all that in. And we're going to do it the way we did yesterday, which is basically making these vertical rectangles, or I like to think of it as coloring with up and down lines. That's really what you're going to do, is sweep all the way across and you're coloring like this. And we had a formula for it yesterday. We said that you integrate from left to right, x to x, top function, which is the square root of x. What's the bottom function in this scenario? 0, which is really what we did in chapter 4, is we integrated from the curve to the x-axis. So it really is minus 0. And then if you could go, those of you who are fast on your calculator, can you give me a decimal for that? 5.3 repeated he's got. So if we did that by hand, we would have had 16/3. But I'm not going to do it by hand. So now what I'm going to do is the exact same problem a different way. And it's going to be a worse way for this problem, but it's not worse for all of them. So we're going to go draw the exact same picture. There we go. We're going to have the exact same function, going like that. It's going to be bound by the same stuff. I use blue. So it's bound by y equals 0 and x equals 4. But don't color it in yet. We're going to do horizontal slices, which for this one is worse. All right, but it's not always worse. So instead of coloring like this and making the vertical rectangles, what I'm going to do is I'm going to start coloring like this and go make one big horizontal rectangle. The problem has to change significantly and the answer won't change at all. So, because I mean, just visually, you can see I'm going to get the same area regardless of whether I color like this, right, or color like that. So my answer is going to be the same, but the setup has to change. Because now, instead of doing my rectangles from 0 out to 4 vertically, I'm doing them from 0 up to this, right? I'm going up the y-axis. And how high up am I going to go? 2. Yeah, remember that's the square root of x is what this arch is right here. So I'm going to be not coloring from 0 to 4. That would be if I was coloring left to right. I'm going to go from 0 up to 2. So my limits change when I do these horizontal. And the integrand drastically changes because right here, the reason this was dx is because those were the bases, the thing that was getting smaller on all my rectangles. But on this one, that super, super small width is this way. Guess what we call it? dy. Yeah, it's a change along the y-axis. So now what happens is instead of having limits for x and a base that's a change of x and an integrand that's all x, now I've got limits for y, a base that's y, and I need to have my length all be in terms of y. Now up here, to get this length, we did top minus bottom. Guess what you do when you do them horizontally? Right minus left, but here's the problem. I can't say that it's 4 minus root x. I can't do that because root x is the y value, see what I mean? So what I need to do here is I will have a 4 because that is the left function all the way on up here. It's going to be 4 minus whatever this stuff is. So it's 4 minus. The problem is you're super used to having your functions because when you start in Algebra 1, they always say y equals 2x, y equals x plus 1. But those can all be written as x equals. And that's what you need to do here. You need the x value because you're going left and right. So I'm going to solve this for x. What am I going to write? X equals y squared. You can even see it. This is x root x. But I'm going to say, this is y squared. Do you see how it's identical? It's just you're used to going x root x, but only because you did it first, right? It's no more difficult. So this function problem right here is y squared. What you need to do then is take the function and solve it for x. So this becomes that. Now take out your calculators, those of you calculating for me, in Math 9, my new one. It looks very different visually, but I'm getting the exact same answer on Rachel's calculator. She already entered it and she's got 5.3 repeated. So the question is, which way is better? Which one do you think is better? Oh, in this case, definitely the top. And I would always have the vertical go to for all of them. The thing that's a dead ringer for not doing it this way is when the functions look like, I'll show you one, when they look like, I'm paging through here, see this? What's different about that one? They're already in terms of x. So that's for sure an indicator that you should go with horizontal rectangles. Actually, let's just go set this one up. Here's why vertical would be a pain for this. First of all, it's already solved for x, so I'd have to go solve these equations for y, and I don't want to. This is a ways in, but we'll just set it up and then I don't even need Rachel to enter it on the calculator. We'll just leave it. But if you were, don't put this in your note packet, but if you were, suppose John's like, I want to do it vertically. He could. Okay, what he would have to do is start going from -1 to 2, blue minus green, blue minus green, blue minus green, blue minus green, but right here, he's going to have a new setup because right when he hits there and he goes vertical, it's no longer blue minus green, it's what? Red minus green, and he's going to have to accommodate that. Also, because he's going along the x-axis, he's going to have to solve these for x. And that you could, and you'll get the same answer, but this one is one where I'd for sure do the horizontal because all the way along here, I have this curve on the right-hand side. So I'm going to set it up like this. I'm going to color up. So instead of going from -1 over, I'm going to go from down here. Is that at -2? Is that hitting on yours? I crossed it off. I'm going to be integrating from -2, and I'm going to color all the way on up to what? You can see it, 1. Exactly. I'm going to do a dy problem. I'm going to do right minus left. Which one of those is the right function, the 3 minus y squared or the y plus 1? 3 minus y squared. So I'm just going to go, and they already have it solved for me. And again, why will this be the wrong answer? Parentheses. So it's right minus left. And now if you math 9 it, so this is the one rare case where the horizontal is better, but almost always your go-to should be the vertical, and it'll work almost always. And usually you can do all the problems both ways, but I'm going to advise you, do vertical when you can. So let's go back. We're going to go do this one. All right. So it says using a horizontal slicing method. So we're going to go, if it tells you you have to use horizontal, you have to use it. If you're given an option, choose vertical. All right, here you go. You ready, Bernsey? Yes. All right. So I'm going to go grab, and I know I'm paging all over the notes, but I just have a lot of stuff in there. So there's my function that's giving me a big boundary for my area, and then y equals 0. The x-axis is also going to bind my area. So I know right now my area needs to be between those two things for sure. And now they're giving me a third constraint of x minus 2. That's the line. And it goes right here. It goes up 1, over 1, up 1, over 1. It's going to hit here at 2, 0. I'm going to go draw it. Boom. And my region needs to be constrained by all of those. So I'm going to be shading in this. All right? So go shade that in. It says use the horizontal slicing method. If you did it vertically, could you? What would you have to do though? Here, I'm going to go let's go do the vertical setup over here, because I could go vertically. I could start coloring, and I'd say I'm just going to integrate from 0, and I'm just going to do root x, right, minus, what's the bottom function here? What is this bottom function? 0. So root x minus 0. The problem is the minute you hit this spot, what is that spot on the graph? Like once you get to what number, you're going to have to shake it up if you do it vertically. What number is this? 2. You can go from 0 to 2 and do that, and then continue on from 2 to 4, because remember that's the point, 4 comma 2. Square root of 4 is 2. But you have to shake up your integrand, because now when you're coloring, you have a different bottom function. So if you're going to do it vertically, which for this one, why not? Maybe, right? But who's going to have to go first? Top function again, root x minus. But now who's the bottom function? There it is. Yeah, it's the line. And if I were to have Rachel go do this on her calculator, but you don't need to spend the time. You could if you want. Do you mind doing it? If it's a big, long one. You already did it? It doesn't matter. Just trust me, they'll be the same maybe. I don't need somebody to waste their time entering it. But this one said horizontal, and honestly, for this setup, it's probably better. Because when I color horizontally, the same function's on the right the whole time. What function's on the right the whole time I'm coloring? X minus 2, but I can't call it x minus 2 because I'm going to be having dy. I'm going to be going up the y-axis from 0 up to 2. So I just need to make sure I solve this so that my x is in terms of y. So I can't put in an x minus 2. What do I have to put in? y plus 2. Yeah, you can see it. You have to solve that. So y plus 2 is going to be the x value, or the right side. You're doing everything with x's. So that'd be y plus 2 minus, right? And then this, I can't use root x, right? Because that's the y value. I need the x. What is x? Y squared. And then if I were to have two separate people math 9 those separately, the answer is identical, and it's 3 1/3 if you want to write it down. So we'll go do a couple more. You seem to be catching on to this better than usual. This section of this chapter generally is a struggle, but I'm feeling good about it. So we're going to go do another one. On here, does this look like one that you'd probably do horizontally or vertically, just based on how the equation? It looks like it's probably going to be best vertically. This is the trigger for that thought. When they say x equals instead of y equals, that kind of means you're going to be coloring horizontally, most likely. So we're going to go graph it again. Let's go do that. X cubed is the cubic function. In order for you to graph this either by hand or by calculator, you do have to solve it for y. So the graphing part, because your graphing calculator only accepts y equals when you hit your graph option, you do have to solve this for y. So I have x plus 2 equals y squared. And then this is where you have to be careful. What is y? Because I want to be able to graph it. And then I'll decide. Tell me what's wrong with that. It is plus or minus, and graphically the plus or minus contributes, because here's why. It's the square root function whose shout out isn't at 0 like it was on the last one. It's at -2. But if I don't do the minus, then I neglect this part, and that contributes to the intersection area. So you need both of that, so be careful. It's not a function. Why not? Yeah, it fails the vertical line test, but I still need to graph it. So on your graphing calculator, how do you graph something that's not a function like that? Because I do need my graphing calculator to put, yeah, you're going to have to enter it. So I want all of you to do this one on your graphing calculator, not just Rachel and Rowan. Go and enter y equals x cubed. And then in y2, enter positive root x plus 2. And in y3, enter negative root x plus 2, and make it piece all that together. And then this is a fairly small area of the graph, so you might even want to zoom in there. But I need you to graph it. Can you tell me, anticipate why I need you to graph it for me? I need something from you. I do. I need the intersections from you. So this is where, go shade all this in. If I were doing, again, vertical, like I always get people say, I just don't want to learn the horizontal way. You could actually get by most of the time. But you got to be really careful with one like this, because you would do top minus bottom, which would be this positive root minus the negative root. And then once you get here, you're going to have to shake it up. But if I go horizontally, what function's on the right all the time? The cubic. So I'm going to go horizontally on this one. I'm going to integrate from y up to y. So when you guys calc intersect for me, could we have like a couple people do the intersection on the left who've got on the calculator, and a couple do the one on the right? I'm not interested in, like yesterday we were only interested in those x values. What am I interested in today? Just the y values if I'm going to color up the y-axis. So I don't really care about the x because I'm going to go up. So can you guys tell me what this bottom y is? Negative, do you have it? 1 point what? Somebody get me that. I gotta wait. Did you do it yet? Negative what? Well, -1 exactly. Well, that's nice. So from -1 up to, I need the y value of that intersection. Does anyone have that for me? Thank you. 1.79 what? 3. All right, so now that I have my limits, now I need to do right function minus left function, but they need to have y's in them, not x's. So what you have to do is just quickly go up there and look at this. The black function is on the right. It's y equals x cubed, but I can't put an x cubed here. What do I have to put? Yeah, the third root of y, or the cubed root of y. So just be careful with that one. This one's already solved for x, so I'm fine. I need to have them as x equals if I'm doing it this way. I need to have my integrand all y's. Now you could go math 9 it and you'll get the area. And again, could I have done this with vertical? What do you think? I could have. I would have had to have two separate integrals. One for this part where I'm doing blue over blue over blue over blue, and now I'm doing blue over black over black over black. So I'd have to split it up. It wouldn't have been any more difficult, really, I don't think. But that's the process. I don't care about the answer. It's just the process that I care about. This will be the last one I do. Am I going too fast? I feel like this is going fast. I think it feels fast because I'm on here, so I'm not asking as many questions. Slow me down if you need me to slow down though. So we'll go up here and we're going to do this one on the graphing calculator as well. So a lot of graphing stuff. We're going to go do this one, all 4 parts, and then call it a day, I guess. I'm going to go graph e to the x plus 1, which at 0 will hit 2. It's going to climb like that. And you can use your calculator, so if you need that to help you graph, go ahead. 2 minus x squared is an upside down parabola. Notice on most of the calculator ones, you really don't need it to graph them. That'll be an upside down parabola hitting at 2. I'll hit at about square root 2 here. It's going to go like that. My guess is on your graphing calculator, that's really hard to see. So what am I going to tell you to do? Just go zoom in once, if not twice. So can I steal yours? Thank you. So go zoom in once, if not twice on that one. And you had a -1 instead of a +1. I just changed it. Can somebody go get me? Now, take a look. This is all there is for part 1. Go ahead and shade that in. It says find the intersection points, right? I want them in full because we're going to do this one horizontally and vertically. This one I know. What's this intersection point right here? 0 what? 2. A 0 in both of these gives you a 2 for y. So 0, 2, I shouldn't waste time. This one, though, I need. And I want you to get me both coordinates to 3 decimal places. If his isn't right, help me out. He's got 0.71, negative 0.715. Can someone back that? Just make sure. All right, perfect. Thank you. And then I just don't want to use a wrong number because I'm only doing one of these. So those are my intersection points. Yesterday, again, if you're going to be using these a lot, what did I suggest you do yesterday? I'm not going to today, but store them. Yeah, maybe one in alpha A and one in alpha B, but I'm fine with this one problem here, leaving it. Now it says using vertical slices, which, by the way, which method would you choose on this one? If you had to pick vertical or horizontal? Vertical for sure. Right? If you had a choice, it's definitely vertical. They're both solved for y, and when I color in here, there's no even function. Top function's blue the whole ride. So that's an easy one to do vertically. Let's go do that. We're going to go then from left to right, coloring vertically. So what's my bottom limit? Yeah, the x coordinates. I'm going to have everything be dx. My limits are x. The base of my rectangles are x. And am I going to do top, right, minus bottom? And I lost my picture. Which one was the top function? It was the parabola. 2 minus x squared minus e to the x plus 1. And again, I'm doing that over and over, and you're probably sick of it, but don't do that. What am I pointing at? That not locking and loading the bottom function or the right function. Go math 9 that. I do want you to. I do want to compare and show you the difference between the visual of the two processes, but the answers are going to be identical. So go math 9 that. Don't forget your parentheses, and I'll wait. Actually, I do want everybody to enter it. Not working your calculator is kind of deadly this chapter because it's so handy. I'm going to wait till I see it. I've got a couple 0.082, let's call it. Let's go 3 decimal places. 0.082. All in favor say oh. We're good with that? Now, that is the area of that little region. I'm going to now do it horizontally, which is way worse for this problem. But I want you to know how to do it. First of all, when you start to set up your integral, you're now going to be coloring up the y-axis like this. So my limits are going to change. I'm going to go from 1.489, and you'll see why this one gets uglier. 1.489 to where? To 2. However, I got to go back to my picture. Here's my problem. Both of these functions were given as y equals, and I need to get them as x equals because I'm going to be going this way, and I want to know the x value here. So here's the problem. Go write this. Y equals e to the x plus 1. Let's put the other one over here. Y equals 2 minus x squared. Which one's easier to solve for x? Left or right? The left for sure. I'm just going to go, let's just add the x squared over and subtract the y. But then we have to be really careful what we write. Because what is x? It's plus or minus technically, correct? So I'm going to write plus or minus. But in the region that I'm working with, is it the plus or is it the minus? It's the minus, yeah, because it's the x coordinates are negative over here. So I'm going to be picking that for that'll be my left function because I'm going left and right. This is what I was wondering if you remembered how to do from Algebra 2. How do I'm going to y minus 1 equals e to the exit, right? And then how do you get up and get into that exponent? Why does that work? What is a natural log? It's a base e. I'll take that. Natural log is a logarithm, like instead of base 7, it's got a base of e. What is e? About 2.7. See, you've memorized a lot of good stuff, right? But really, what's a logarithm? Do you know? Like, what is it? Nope, it has nothing to do with the derivative. Like, if I were to say what's ln e, what do you tell me? Why? Because you memorized it. Ah, that's it. It's an exponent or a power. It's the power that you raise the base to get e. It's asking you for the exponent. So when I say what's ln 1, it shouldn't be memorized. It's e to what power gives you a 1? What's the answer? E to the 0. So it's the exponent. That's just a little Algebra 2 review. But when you natural log both sides of these, the ln and the e are inverses. They undo each other. That's our new x. So now let's go create our integrand, and that will be it for the day. I need to go down here, and now I just need to do right function. Which one was on the right? The natural log one? So that's ln y minus 1 minus the left function, but be careful here. Are you getting why I'm saying be careful? Because it is a negative. Yeah, it's the negative. So we're going to have to do minus a negative, which is going to make it a plus. And it was root 2 minus y squared, is that right? Or y squared minus 2. 2 minus y, thank you. Now I do want you to go enter this. You might say, well, how do I enter the y's? Your calculator couldn't care less what variable you use. You can call it ln p minus 1, but as long as you put dp, it doesn't matter. So what am I going to tell you to use? X. Just use your X button. Your calculator has no clue you're coloring horizontally. It just needs to evaluate the integral. If you have OCD and it bugs you to enter X on your calculator when you see a Y, then go use alpha 1 and do it with Y's. It doesn't matter, but I always just use X's. What's our answer? Exactly the same, right? It better be, or we've made a huge error because I'm coloring the same picture. I'm just coloring it like this versus like this. What do you think? Do you get it? This is usually a hard section. You guys seem to really be picking up what I'm shoveling here today. So your homework is these 4 questions. I'm going to pass it out. There's one, my proctor retyped this for me and she forgot the interval on one of them. So you have a good half, you might even finish this in class today. I can collect it if you want to get rid of it, but write due Monday on the top. It's a little different than a standard homework assignment because what did I say this is? This is a problem set, so they're each worth 4 points. It'll be 16, and then what category do I put it in? This goes in the test category. So, yeah, I'm going to go help you out. I'm going to wait till everybody has one. So to get the full points on every problem, which you want to when they're with homework, I get sometimes we cut some corners here and there, but in this one, you want to make sure you get 16 out of 16. Read the directions. Number 1 says just set it up. Does it say you have to evaluate it? It means I'm going to give you your 4 points for your limits, your integrand, who comes first, who comes second, but I don't care what the answer is, so just leave it undone. Number 2, it says to do what? Sketch it. So I'm going to be looking at your sketch. Okay. It says find the area. And what did I say to do? Integrate by hand. If you math 9 and plop down an answer, you're going to lose 2 points because that one, the point is to do it by hand. It's the only one. Okay. On the back, number 3 is the one that she forgot to put the limits on. Okay. So you're going to be doing the sine wave intersecting with the cosine wave, and they intersect, there's a whole bunch of lobes that get made. And when you intersect them, I want you to do the lobe between 5 pi over 4 and 2 pi. So I want you to do it'll be the first lobe you see, and you'll know what I mean by a lobe. You're going to graph it, and they're going to cross and make these little lobey things as the sine wave and cosine wave cross. I just want the area of one of them. And that one's calculator active as well. So that's it. This one's due Monday.